Hello, welcome back to organic chemistry. Today we're talking about the aldol reaction, right? Specifically, we're going to talk about the directed aldol reaction, okay? This is going to be a little bit different than the other aldol reactions we talked about. We talked about just aldol reaction in general. We talked about the cross aldol reaction. Now we're on to the directed aldol reaction. And what's really nice about the directed aldol reaction is we're going to focus on making the enolate first, and then we're going to add in our carbonyl that are going to react with each other, okay? It's very directed, very focused. We're not going to see a mixture of products. We're going to get the product we want, okay? So let's start with we can start with something like this, like our carbonyl. And say I want to add in this carbonyl. And we want to add these together to give us one product, right? I want to get one specific product, okay? And I want to get something like this. I want to add this in here to get that, right? I want to make that just by itself, okay? And notice here, we're not even making the alpha unsaturated, we're making the OH group here, okay? How are we gonna do that? How are we gonna make sure that we're only gonna make this into enolate and that I'm only gonna attack this, right? Well, the way we're gonna do this is we're gonna use a very strong base to make sure we get 100% of the enolate formed of the one we're interested in. And then the second step is then we're gonna add in our carbonyl, okay? We're gonna do some steps in process. So let's see how we can do this. What we're gonna do is we're gonna go ahead and I'm going to add in our base, our LDA, right? We talked about LDA in the past, right? LDA is going to be a very, very strong base. And what our LDA is going to do, as we talked about it, and if we can draw the structure of that again, I'll draw it out down here. Right? LDA, lithium diisopropyl amide, right? It's going to be a very, very strong base. This nitrogen is very basic, but it's very sterically hindered. So it's just going to work as a very, very strong base, but not as a nucleophile. And so what we're going to do is we'll be able to deprotonate this. And just for this one time, I'll draw it out for you. This is going to go here, boop, like that, okay? Notice that all I'm doing is taking this reactant with LDA to give me the enolate, right? We haven't introduced our carbonyl yet. We're doing this in steps. This is going to be step one. All right, so now we've made our enolate, right? We have our nice enolate made. Then in step two, this will be step two. Now we're going to introduce our carbonyl, right? This is going to be in step two. Step two is addition of the carbonyl. So we're going to first add in our carbonyl with LDA to make our enolate. These are going to react together. Once we made our enolate, then we're going to add in our carbonyl, right? Once our enolate is made. And remember, this is a very strong base, so it's going to deprotonate all of our carbonyl to give us all enolate. We're going to get like 100% of this enolate, right? 100% of this, right? Because this, again, is a very, very strong base. So we get all this. We're not messing around. We're making the enolate. And then this is then going to come and attack the carbonyl. And we're going to come down here. And we get to here, right? We've generated this structure here where we can see we have our new bond being formed right here between this lone pair of electrons and that carbon, the carbonyl. We make a new bond there, okay? That's our new bond there. We have an oxygen there, negatively charged. What are we gonna do? We have to protonate that, right? What are we gonna do? Well, we add in our base the first step. Second step, we add in our carbonyl. The third step is we're gonna add in our water. Okay, add in our water. We're going to take the oxygen, it's going to rip off that hydrogen there, and it's going to generate our final compound. And we get this as our final compound, right? Now notice, look at what we've made here. Before we always talked about, well, this is not very stable, right? We're always going to move into the alpha beta unsaturated carbonyl. But in this case here, in our third step, we're adding in water. We're diluting with lots of water. So in this reaction here, when we're adding in the water, there's not really much base in there anymore, right? There's not a lot of base in there. It's not high temperature. So we're going to actually be able to isolate this compound here, this beta hydroxy carbonyl, right? We're a hydroxy group at the beta position, alpha, beta, right? And so we can isolate this compound and make this one. This is with our direct aldol reaction. because there's no base in this step of the reaction, right? There's just a lot of water in there. We diluted it out. So there's just water and there's no base in it, okay? So we're able to stop this compound. Now, if this had exposed to a lot of base and heat, then it would make it would form the alpha band saturated carbonyl, okay? But in this case, we don't have that one, right? So this is a great way of directly making our carbonyl into an enolate and then taking that enolate and attacking a different carbonyl, right? So this is our directed aldol reaction. It's a great reaction to do. We can get to this compound here with our beta hydroxy carbonyl here, okay? So that's how we can do this. Now, we can see what it looks like synthetically if we were to write this in steps, right? That's a mechanism. And so synthetically, when we write this out, it could be something like this. We have our carbonyl here. Step 1 would be LDA. Step 2 would be our second carbonyl, and we'll draw it in. And we'll draw something like that. What the heck? So this is our carbonyl. Again, it doesn't matter. It doesn't matter if I have other alpha carbons here or hydrogens on it, because this is going to be make the enolate. All this is all going to be turned to enolate, which then will attack that. And our third step is then addition of water, right? So we'll do this over 3 steps. LDA makes the enolate, and then we're going to add in this group. And then the third step is going to be addition of water to quench everything, right? To get that that beta hydroxy carbonyl. So let's draw what it looks like. What would that look like? We have our carbonyl here. We're going to make a new bond here, right? This new bond here is going to be, the enolate here is going to attack that carbon there, right? That's where our OH is going to be, right? Then we'll draw the rest of the molecule, okay? So what's happening here is this enolate is going to attack that carbon. Electrons come up, and we're going to protonate those ones to give us this compound. So this is what we're making here, right? We've made this new carbon bond. That's the important thing. We made a new carbon bond between where the enolate is going to be, where the enolate was formed at, with that carbon, the carbonyl, which is right there, okay? So this is a great way we can specifically make an enolate, which is going to then attack a carbonyl, right? We don't have to worry about there's too many alpha carbons or anything, right? It's not going to affect us with this directed aldol reaction, okay? Now, a couple things we didn't talk about, and then we'll talk about in future videos. One thing, notice that my carbonyl here, every time I make the enolate with it, notice I'm using a symmetrical one, right? I haven't used an unsymmetrical carbonyl to make my enolate. Another thing, look at my LDA. I didn't really add any reaction conditions with it. No heat, didn't talk about the temperature or anything like that, right? Does that matter? That could be. We'll talk about it a little bit later, right? Those are things we'll talk about in future videos. So make sure you watch the more videos to learn more about that, right? What happens if we don't have a symmetrical carbonyl? Is that going to matter? What about conditions? Do you have specific conditions for LDA? We'll talk about that, right? But for now, we can do this directed aldol reaction. And using these 3 steps here, we can be specific and make what we want to make, which is important. That's what we want to get to, okay? So this is our directed aldol reaction.